everybody, this is 1.7. This is absolute value inequalities. So basically what we do in this section is we take what we did in 1.5 with inequalities, we take what we did in 1.6 with absolute value, and we smush them together. So you're going to use both of those sets of skills to do this. So when we start with solving absolute value equations and inequalities, there are three different things that can happen. If a is a real number and it's greater than 0, we can have an equation. And here's one form. We can have x, absolute value of x is equal to a, so x equals negative a, or x equals positive a, and this is what it looks like on a graph. It's just points on a number line. We can also have it where absolute value of x is greater than a. There are two cases here, are that first case, x is greater than a. The second case is x is less than negative a. Notice that when I do the negative case here, the inequality sign flips direction. Okay, and then that's that graph. The other case is that absolute value of x is less than a. And what happens is its absolute value is x is less than a, or x is greater than negative a. Okay, I can combine this. I can write this one the other way. And negative a is less than x, so that I can write these two like this in consecutive order as one inequality. So all it says basically is x is between positive a and negative a. So we're going to use all the skills we have now all together, and this is how it will work. The steps for solving an absolute value equation still have to apply. It's got to be that standard form like this before I do anything, and this one is not. Okay, so I'm going to put it in standard form first. Absolute value of 3w plus 1 is less than 11. And now I'm going to make my two cases. 3w plus 1 is less than 11. And then when I do the second case, 3w plus 1 greater than negative 11. So I flip the sign. Okay, now I'm just going to solve, just like I've been doing. Okay, 3w less than 10. 3w greater than negative 12. Divide by 3. Everywhere. W is less than 10/3. And W is greater than negative 4. Now I just have to graph that. So I'm going to put 10/3 over here. And I'm going to put negative 4 over here. These are open circles, right? Because there's no equal to sign. W is less than 10/3. So this guy is going to go this way. But it's greater than negative 4. So it's this space here in between. Okay? That's the graph. That's how we do this. Same skills, just a different story, okay? So this is the next one, right? This one works just the same way. It is the same process. If I was to write this one, sorry, let's go back a step and write it in interval notation, it would be from negative 4 to 10/3. Okay, good practice. This one, you can go through and solve. You're going to get in interval notation that x is between -7 and 2 inclusive. So the graph would be like this. -7 colored in, +2 colored in. There you go. Okay. All right, let's try another one. Come on, slides. All right, same idea here, right? I'm going to do exactly what I've been doing. I have to move the 1 over first. So I get 2 is less than or equal to the absolute value of half t minus 5. Now I need my two cases. Works the same way. I'm going to flip this over just to make it a little more comfortable. So the first case is half t minus 5 is greater than or equal to 2. I just wrote it in the opposite direction. Case 1. Case 2 is half t minus 5 is less than or equal to -2. Well, great. I'm going to do all the things I need to do. Oh, I lost the t on that one. So I get half t is greater than or equal to 5. And I get half t is less than or equal to 1. multiply both sides by the reciprocal. Keep dropping the t over there. I get, on this side, I get t is greater than or equal to 10. On this side, I get t is less than or equal to 2. All right. That is not the end of the world, unless I did something. Oh, why did I, friends? Somehow I'm adding 3 instead of 5. What is happening there? I don't know why. I knew something was strange. Where did I get 3? So instead of 3, I'm going to add 5. Oh, my good gravy. I catch the mistakes. It just takes me a second sometimes. So half t greater than or equal to 7. Half t less than or equal to 3. Multiply by 2. This is 14. This is 6. Whew. All right, so now let's read what it says. This one says t is greater than or equal to 14. Well, it's a closed circle, 14's included, and I'm coloring greater than or equal to out that way, right? T is less than or equal to 6, so that's a closed circle at 6, and the numbers less than are this way. So now writing that in interval notation, just like this is in 2 parts, I'll need 2 parts in my interval. So I'm going to have from negative infinity to 6, hard bracket at 6, and from 14 to positive infinity. All right? So this is an example where they go in opposite directions. Here is the next one. You can try this. Use the last one as your example, okay, to help you. I'm going to scroll that down maybe. Oh, I'm apparently just going to flat move the slides. All right. Let's put that back where it belongs. For this one, your final answer should be that the absolute value of c is between -9 or negative infinity to -9, or from 15 to infinity. This is soft brackets because there's no equal sign there, and you'll be able to make the graph. This should be what your answer looks like. Okay, so let's try another. Solve the inequality. So I'm going to subtract and do my job the same way. 3d minus 5. Absolute value of 3d minus 5 is less than or equal to -3. Here's the thing. Can the absolute value of something be less than a negative? Of course not. It can't be like I can't get -4 out of that or -3.5. So right away, I'm not going to do any more work. I'm going to say that there's no answer here. Okay. All right. Cool. Let's try this one. This one is pointed the other way. So let's see what happens. I'm going to subtract 7. I have the absolute value of 3d minus 5 is greater than -3. Well, listen, we can work it out, but here's what's going to happen. I can do my 2 cases, 3d minus 5 greater than -3, 3d minus 5 less than +3, plus 5. I'm actually going to add 5 this point instead of some other number. I'm going to get 3d greater than 2 and 3d less than 8. Okay, 3. So I get d is greater than, 2/3. D is less than 8/3. Okay. So let's find out what that looks like. Well, sorry, I'm just checking to make sure I didn't do anything silly while I'm sitting here. So I have 2/3, and I know 8/3 is larger. I have open circles. It's greater than 2/3 and less than 8/3. And there we are. Okay? You just got to keep doing the work here. All right. You are going to try these two. Works the same way. Okay, 2 different cases, very similar. All right, we are going to solve this one. So in this case, I already have it in my standard form, right? So I'm going to make my two cases. 4x plus 2 is greater than or equal to 0. 4x plus 2 is less than or equal to negative 0. Here's the thing, I don't care about negative 0. Okay, so I really like negative 0 and 0 are the same thing. So I am just going to be here. Okay, so move 2 over, 4x greater than or equal to negative 2, divide by 4, divide by 4. X is greater than or equal to negative a half. It's fine. Okay, that's it. There's going to be one answer here. So in my interval notation, it's going to go from there to there. Oh, should be a hard bracket there, greater than or equal to. All right, let's try another. This one looks the same, okay, but it's not included there. So the difference is going to be, I can't, wait, let me go back. Oh, I know why. I know what's wrong here. I do really need to do this half. This is why. Because as much as negative 0 doesn't matter, I'm silly, having it solved in that direction does. Okay, so now I'm going to do the other side because I need to flip that sign. Okay, because there's two parts to this. X is greater than, less than or equal to negative a half. So what happens here, my brain got ahead, my pen got ahead of my brain, is that x is greater than or equal to negative a half and it's less than or equal to negative a half, which means that it's really just going to go from negative infinity to infinity. Because if at half, negative a half, it's included and it's going both directions, that's everybody, okay? When I have just this inequality sign, when it's just greater or less than, it's the same process. It would be negative 0, but I don't need to do that. And here's the thing, I'm going to get the same answer. X is greater than negative half. X is less than, less than negative half. The difference here is that at negative half, it's not included. Okay, so I can go either side, but that half, that negative half itself is not on the list. So when I write that in interval notation, I have to account for that. So I'm going to have the negative half there, and from negative a half, but it's not included, up. Oh, I'm getting an extra menu instead of writing on my screen. Okay. The last case that we can do with this is if 4x plus 2 is less than or equal to 0. So we did greater than or equal to, we did just greater than, or we have less than or equal to. So we got to think about what that means. 4x plus 2 less than or equal to 0. 4x plus 2 greater than or equal to 0. So I get the same answer. I'm going to have x less than or equal to negative half, x greater than or equal to negative half. Here's the thing. For this answer to come out less than or equal to 0, the only thing that's going to work is negative a half. Because if I put in negative a half here, I get negative 2 plus 2 is 0, right? Anything less than that, I can't get a negative answer out. So the only case here that really matters is this one. Because less than 0 is goofy. Like I could put in a negative 3 in there, but I'm not going to get something that fits that because I'm not going to be able to get a negative answer out, right? So I have to think a little bit about what this is. So in this case, the answer is going to be x is equal to negative a half. That's the only thing that would be okay. So it would be just that guy, okay? All right, let's see what happens next. So this is practice for that. Remember, what's going to happen here essentially is that in this case, everything's going to work. Greater than or equal to 0. Basically, anything that comes out of an absolute value is greater than or equal to 0. In this case, there's going to be something you have to exclude. Okay, there's going to be one spot doesn't work. And then in the last case, what's going to happen is there's only going to be one spot that does work, because anything else is going to be less than 0, is going to be negative, and I can't get a negative out. So something is going to equal 0 here. That's the only case. All right. So there is a section in here about using the point test method to solve an absolute value equation. Honestly, you have a way at this point. It's sort of torture. So it's in here. It's in the notes. It's fine. Alex is going to ask you to try it, but here's the thing. You can solve it the way we've been solving it, and you'll still be just fine. So I'm going to skip those because I don't think they do you a whole lot of extra good here. I think it just sort of confuses the one process you have with a new one that you probably won't use anyways. So we're not going to do it. So we are going to do one last thing in here, writing absolute value inequalities. So we're going to write an absolute value inequality to represent the words. The one we want to represent here says all real numbers x whose distance from 0 is greater than 5 units. Okay, so I think the first thing we have to think about is what that actually looks like. So I have 0, and I want to go 5 spaces away. That's 5. And 5 spaces away, it's negative 5. And it's any real number outside of that. It's greater than, so that 5 is not included. Okay, so really I have x is less than negative 5, and I have x is greater than 5. Well, what absolute value equation does that fit? Really, it fits the absolute value of x is greater than 5, right? Because if I had to solve that, I would keep the one I have and then flip for the second equation and negative. That's what that would look like. Try another. All real numbers whose distance from negative 7 is less than 3 units. Okay, well, let's think about that. All real numbers whose distance from 7, negative 7, so I'm going to put negative 7 there, and I'm going to go 1, 2, 3. So that's negative 4. Go 1, 2, 3. That's negative 10. So it's less than 3 units. So it's open circle. Their distance is smaller, so they're in the middle here. All right, so how do I express that? Well, it's really something, and I moved away negative 7, right, is less than 3 in either direction, right? So x plus 7, something plus 7, the absolute value of that, that's a 10, is less than 3. Something and 7, that distance has to be less than 3 total. That's what this says. Okay. Try another. All real numbers whose distance from 0 is greater than 10. It's just like the first one we did. Draw it, see what it looks like. What you should get is 10. Oh gosh. Absolute value of x greater than 10. Okay. The second one says all real numbers whose distance from 4 is less than 6 units. So this number here is the one that we're setting on the other side. So 6 is greater than something. What's over here is less than 6. And we're calculating a distance away from the number 4. And that's how that works. The absolute value of x plus 4 is less than 6. All right, now let's use it for something. Latoya measured a certain compound in a scale in Chem Lab. She measured 8 grams, but the scale is only accurate to 1/10 of a gram. Write an absolute value inequality to express the interval for the true mass x of the compound she measured. Well, she measured something to be 8, right? And she could be off by 1/10 in either direction. So it could be 8.1, it could be 7.9, right? So the distance here is 1/10. The distance here is 1/10, right? So distance from 8, okay? That's what I'm thinking about, the distance away from 8. Oh, boy. The distance away from 8, x minus 8, in either direction has to be less than or equal to 1/10. Okay? Because it says it's up to 1/10, so that would include it. All right, let's try another one. Von Zell mounted a piece of metal in her machine shop. She measured the thickness at 12, and it's accurate to 0.05 of a millimeter. Write the interval. So it's accurate to 12. So I want to find the distance from 12 in either direction. And it's accurate to plus or minus 0.05. That's all. Okay. Come back and look at the examples if you need extra help. But this is the end of 1.7, and this is the end of what we do in Chapter 1. Thanks.